Welcome to Elements of Chemistry. In this episode, we're going to talk about using numbers. Numbers are used in calculations all throughout chemistry, and the numbers we use in chemistry are either very large or very small. So we use scientific notation to express very large numbers or very small numbers so that they're more understandable, easier to write, and most importantly, easier to perform mathematical operations. You don't get lost putting all those zeros into a calculator. Numbers are written in correct scientific notation, have a single digit in the ones place, followed by a decimal point, and then the rest of the numbers that are significant. And then what you use is times 10 to some exponent or power. So if we look at this, we're going to have a number between, actually, it should be 1 and 9, a decimal point, and then the rest of the significant digits. The reason we can't have a 10 there is 10 is a two-digit number. And for scientific notation to be correct, it's got to be a one-digit, single-digit number, then the decimal point. And then the exponent is really important. If it's a positive exponent, it means the number is greater than 1. A negative exponent is how we express numbers that are smaller than 1. And n is the number of decimal places, of the number of places the decimal points had to be moved. So if we look at this example, we have 7,890. Well, we could express that in scientific notation as 7.89 times 10 to the third power. It's a positive 3 because 7,890 is greater than 1. So if we look at it, the single digit numbers are the ones that are the hardest. Everybody messes these up. If we look at the number 1, the decimal point normally would live right here after the ones. So we're not moving the decimal at all. So we just go 1 times 10 to the 0 power. That's how you would express a single digit. So 9 would be expressed as 9 times 10 to the 0 power, or 6 would be 6 times 10 to the 0 power. Now, if we look at the digit 10, the decimal point normally lives here. It's going to have to move one place to the left. So that would be 1 times 10 to the first power because we've moved that decimal point one time. And the number 100, we're going to move it 2 times. So 1 times 10 to the second power. 1,000, 1, 2, 3, 1 times 10 to the third power. Now you're going to wonder, where did all those zeros go? Well, those zeros were just functioning as placeholders. So we don't really need to include them unless they were what we would call significant for significant figures. And that'll be addressed in a later video. So now let's look at some of these that are less than 1. Now we're going to move the decimal to the right one place. So it'd be 1 times 10 to the negative 1. The negative indicating that the number is smaller than 1. Not a negative number. Remember, if we were going to make it a negative number, we would have to put the negative sign out in front of the entire digit. Here we're moving it 2 times. So 1 times 10 to the minus 2. Here we're going to go 1, 2, 3. 1 times 10 to the negative 3. Now, quite often you'll see your zeros grouped in sets of 3. It just makes counting them much easier. So there's 3. Then we moved it the fourth time. So 1 times 10 to the negative 4. Here's another set. I'd like you to try these on your own, and then we're going to check and see how you do. So we're going to give you a minute to check these numbers. Okay, let's go ahead and check these works. Okay, 10,000 is greater than 1, so we know it's going to have a positive exponent. Sorry, my puppy is being whiny here. We're going to move it 4 times, so 10 to the fourth power. Here we're going to move it 5 times, 1 times 10 to the fifth power. Now we're going less than 1. We're not negative, we're less than 1. So 3, 4, 5, 1 times 10 has to be a negative 5 because it's less than 1. There's 3, 4, 5, 6. 1 times 10 to the minus 6. Okay, so why do we worry about doing scientific notation when we can put these numbers just in a calculator and use them? Well, sometimes these numbers are really, really big, like Avogadro's number. It's 6022, and then there's going to be 20 more zeros after it. So it's easier to put in 6.022 times 10 to the 23rd. Um, when you put in a lot of zeros, it's really easy to make a mistake in a calculation. So the regular numbers are called expanded form, and then we're doing scientific notation. So let's try taking some of these from scientific notation back to expanded. And it works the same way. This says we've got a number, it's positive exponent. This number is greater than 1. So we're going to be adding zeros or moving our decimal point to the right. It was here, so there's 1 place, 2 place, 3 place. So 2.9 times 10 to the third really is 2,900. Here we have a negative sign, so we're going to have to move it the other direction. So we're going to start this way. There I've moved it once, twice, 3 times. So now my decimal point lives right here. And I want to talk about zeros here for a second. When you have a number that starts with its decimal point, yes, it is mathematically correct to leave it that way. But in a lot of professions, they find it better to put in that leading zero to show that you can see where that decimal point is. Decimal points are tiny little dots. It's really easy to lose them. And if you're in a hurry, we need a way to identify that decimal is there. So we tend to put that decimal right there. Okay, here's one that's larger than 1. So we're going to move it 3, 6, 9 times. So 3.7 times 10 to the 9th. Less than 1, we know it's going to have a negative exponent. Now notice I do that right off the bat because I don't want to miss that negative sign. So I'm going to move it 3, 6, 9 times. 6 times 10 to the minus 9. Here's another one. It's a negative exponent. So we know that our number is going to be less than 1. That's a 6. That's a 6, not a 0. Let's make that look more like a 6. There we go. So here I've moved it 1, 2, 3, 4 times. I put the decimal point here. We can always double check to see if we were going to take this back the other way, we would have moved the decimal 1, 2, 3, 4 times, and that gives us that. So you can always go back and check when you're going from scientific notation to expanded. Okay, here we've got 4.72 times 10 to the third, positive exponent. So we know that our number is going to be greater than 1. So here we've moved it 1, 2, 3 times. Here's a big one, 10 to the 9th. So 6, there we've moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Now the decimal would be inferred to be right here. And stick in our zeros. And on these ones that it's kind of confusing, sometimes it's always good to go back and double check to make sure you know what you're doing. So we're going to move it 3. There's 3, 6, 9 times takes it back to where it was. And always don't forget a number in the ones place. You're going to put the digit. We haven't moved the decimal at all, so 10 to the 0. So now it's time to test yourself. You can go ahead and pause this video for a moment, do these digits, see if you can put them into scientific notation if it's already in expanded form, or if it's in scientific notation, put in expanded form, and then come back to the video and check yourself. Remember, all of these videos are designed to be done in less than 15 minutes. So you should be able to do this pretty quickly. Okay, hopefully you're back now. Let's go ahead and look and see how you did. Here we've got a expanded form, so we're going to put it in scientific notation. So remember, we're checking yourself. So let's see how you did. We're going to be moving it 1, 2, 3 times. So 4.9, it's going to be a negative exponent because this number is less than 1, 3. Excuse me. Here we've got a number that's greater than 1. So we have a positive exponent. Decimal lived here. 1, 2, 2, 3, 4. So 4.29 times 10 to the fourth power. Remember, leading zeros and trailing zeros we don't put in here unless they are significant, which we'll get to later. Okay, here's another one that's less than 1. So we put our negative exponent in. And remember, to get a single digit in the ones place, we're going to move it 2 times. So 6.71 times 10 to the minus 2. And 12, we're just going to be moving it 1 time. So 1.2 times 10 to the first. Got a couple more that snuck in. Okay, let's look at this. 4.2 times 10 to the minus 4. So this is going to be less than 1. So we're going to put the 4, 2. We've moved it 1, 2, 3, 4, decimal point, nice and clear. And let's put that leading 0 to indicate we know where that decimal point is. This is going to be 9 times 10 to the 0 because we haven't moved it at all. Now let's look at these last couple ones here. And to test yourself here. Let's pause the video and then come back to it. Okay, hopefully you're back. Here we're going to have to move it. This is very much a negative, less than 1 number. We're going to have a negative exponent. We're going to move it 3, 6, 9, 12, 15, 16 times. You could see where if you're going to put this number in the calculator, it would be really difficult to make sure you had all those zeros. 9 times 10 to the second power, because it's greater than 1. Here I've moved it 2, 3, 4, 5, 6, 7, and put in our commas to make our number neat. Excuse me. And number J, find the mistake here. You find the mistake in 0.24 times 10 to the fifth. Hopefully most of you saw it. Remember, it's got to be a single digit in the ones place, so this has got to be 2.4. Okay, you've got to always move it over 1. So let's look at this. What would that have been in expanded form? Well, in expanded form, this is a bigger number. We're going to be moving that decimal point 5 times. So that would have been 2, 4. That's 1 move. 2, 3, 4, 5. So when we go back to scientific notation, is that right? Let me make sure I do this right. 1, 2, 3, 4, 5. One too many zeros. I knew I made a mistake. Always go back and double check. So this really should have been 10 to the fourth power. Give yourself 10 points for each of these correct answers. And in our next video, we're going to do some math with scientific notation. I hope this helped. As always, stay curious, be kind, and stay safe out there. Have a wonderful day.